Hello, everyone. Welcome back to the session, day 7 of our training on SQL. In the previous session, that was yesterday's class, we looked at select statement. We looked at a few more options under select statement, CRUD operations, where we focused on the update and delete commands, aggregate functions, summation, average, minimum, maximum, count, distinct count, all these. We understood what is the purpose of the group by clause. When you want to aggregate the data, you can use it. And we saw when to use the where clause and when to use the having clause. We tried to understand the difference between them. So where is applied before the group by clause. And we need to remember that where condition works with row level data. Having is applied after the group by clause. So after you have grouped the data, on the aggregated result, if you have to put a condition, after having grouped the data, on the aggregated data, if you need to set a condition, then you can make use of the having clause. Having comes after group by, it works with aggregated data. So this is something that we clearly established yesterday. In today's module, we are going to talk about joins and unions. That is the agenda for today's session. So I'm already connected to PG admin tool. But before I give you a practical demonstration of joins, first we will go through the concept of joins. What is it? What does it mean to join the data? And why is it necessary? So here I have a sample. Okay, let's say we have two tables. Okay, very small, tiny tables I'm using just to drive the concept. Okay, let's say we have two tables. One table is the course details. So I have information about the name of the student and the course to which the student is enrolled in one table. In the other table, I have the student personal details, like what is the name of the student and the age. So if I need to create something using the data present in the course table, I just need to know what is the name of the person and the course to which the person is enrolled. If I access this table, fire a select query on this table to retrieve the data, it would be fine. It will work. If I need to know personal details about the student, like the name and the age of the person, then I will access information coming from the student's detail. Okay, that table which contains the student's personal information, and I can create whatever, further visualizations or whatever I might want to create with that data. But what if we need data from both the tables together in order to present it in a report or in order to analyze the data? How do I combine the data coming from two different tables, merge it into one single table? That is where the concept of joins will come into picture. Okay, so join is a procedure. It is a concept wherein we take data that is stored across multiple tables and combine it and create a much bigger virtual table with that data. So join is a method of combining the columns from various tables, okay, and storing that data, the combined data. And when we say we are going to combine the columns, so two columns from here, two columns from here, when they get combined, we get a big table which is extended horizontally with 4 columns in it. So how do we join, and what is the prerequisite to join the data from different tables? In order to join the data from different tables, the prerequisite is there has to be a common field on which we can join the data. Only when there is a common field, it will be possible to join them. If there is no common field, then those tables are referred to as disjoint tables. And it will not be possible to join them. Okay, only when there is a common field, we can join the data. So here, is there a common field between the two? Yes, name is present as a common field. So name, which is the common field, will be used to write the join clause. We will write the join clause on the name field. So we will tell to join the data between both the tables using name as the join clause. As long as there is a common field, we can perform the join. Okay. Now, what are the different types of joins that we can perform? There are quite a few, but these are the most important ones. Inner join. What will inner join do is, it will give us matching data from both the tables, matches based on the join clause that we write. Inner join will fetch matches from both the tables. Okay. It will give us matching data from both the tables based on the join clause written or join clause given. Okay. So let us say here my join clause is the name field. I want to use the join clause as name from the students table should match with the name from the courses table. Courses table name should match with the students table name. This is my join clause. Name equal to name is my join clause over here. Okay. So only when there is a common member, only when there is a common member where names match, we are going to take that data. So how will this work? This is my join clause. Name equal to name is my join clause. Okay. Then if I say I want inner join, what will happen? It will look, okay, name from here should match with the name from here. That is our idea. Name from the course details should match with name from the student details. This is called, this table is course details. Okay. And this table here is the student details. So name from here should match name from here. That is what we are telling. That is our prerequisite. Okay, so it will check A. First name is A. For A, is there a matching record over here? There is no match. So when matching data is not there, that record will not participate in inner join. It will not get involved. It will not be able to participate in inner join. Why? Because it doesn't have a match on the other side. Inner join gives only matching data. All right. And for A equal to A, there is no match. So A will not come in the result of inner join. It will not participate. For B, there is a match here. So for record B, for student B, there is a matching record in the other table. So B will line up with B, forming a row. Then C, is there a match for C? Yes. So C will line up with C, forming a record. For D, is there a match here? Yes. So D will line up with D, forming the record. So we have information for D. Then it will check B matched with B, we already have the data. C matched with C, we have the data. D matched with D, we have it. Already it happened, the join happened. For E, it will now check. For E on this side, is there a match on the other side? There is no match. So E will not participate in inner join. Okay, so what is inner join? It will give us only those records with matches from both the tables or from all of the tables that we are trying to join. It's not like we can join only 2 tables, 3 tables, 4 tables, 5 tables. How many ever you can join, provided there is a common field on which you can mention what should be the join clause. Okay, you can join as many tables as you want, depending on your requirement, provided there is a common field between the tables in order to mention the join clause. So this is inner join giving us matches from both tables. Another way in which we can join the data is left join. So with left join, what will happen is we will get all the data from the left-hand side table. So if I say course details, left join with student details. Okay, course details must perform a left join with student details. Then this becomes the left side table. Everything from here will just sit in the output. All the records from here will come and sit in the output. Okay. All the records from here will come and sit in the output. Then from the right side, what will come? Only matching data will come. So with LeftJoin, what happens is all the data from the left side table and matches from the right side table will appear. For those records without matches, okay, for the data on the left side, when there is no match on the right side, null padding will happen. Okay, for the records on the left side with no matches on the right side, null padding will happen. Null padding will happen. Now, what does this mean? Okay, what does this mean? So what essentially happens over here is we get everything from the left side and we get matching data from the right side. Okay, let me undo that. Please see here. So all the data from the left side, A, B, C, and D, they came and sat here. Okay. Then from the right-hand side, where we have name and age, what is happening is wherever matches are there, they are coming. Okay. So for A, there is no match found here. When no match is found, null padding happened. We got all the data from the left side, A, B, C, D, everybody came. And for A, it tried to see if there is a match here. It could not find a match. So when matches are not found, null padding will happen. Null and null means blank. It will be left blank. Null means no data. Null means there is no data found. For B, match is found and it has formed a record nicely. For C, match is found and it formed a record. And for D also, there is a match found and it formed a record. Now, what about E? Why did E not appear over here? Why did it not participate in the join? Because E is a record that is exclusively present in the right-hand side table. And this is LeftJoin, where we get all the data from the left side and matches from the right side will appear. Okay, so because this is LeftJoin and our point of interest, our focus is on the data from the left side, and to bring only matching data from the right side, something exclusively present only in the right-hand side table will not get involved. And for those records on the left side with no matches on the right side, nulls are padded. So this kind of an output we will get when we perform LeftJoin on these two tables. The other type of join is RightJoin. It is exactly the vice versa of LeftJoin. It goes the other way around. So here what happens? Focus shifts to the right table, data in the right table. So if I say course details, RightJoin with student details. Course details, RightJoin with student details. This is my right-hand side table. So we get everything from here. All the data from the right side will come, okay, into the join output. And for every record over here on the right side, it will look for a match from the left. If a match is found, like for C, B, C, and D, matches are there over here, B, C, and D, they will line up forming a row. And for any particular member on the right side, with no match on the left side, null padding will happen. So we got everything from the right side table, matches from the left side have been brought, and a record with no match, null padding happened. Then what about A? Why did A not get involved here? Because A is present exclusively in the left side table. And our focus is to work with the data in the right side table and only bring matches from the left side. So our focus is right side now. Okay, the king of here of the protagonist, the main table here is the right side table. We get everything from there, and then matches are brought from the left side. If a match is not found, null padding will happen. But something exclusively present on the left side will not get involved. A did not participate. Okay, then there is full join. With full join, what happens is we want everything full. Everything from the left side table, everything from the right side table, everything should come. Okay, and when they come, all the matching records will line up. It will not just come in a haphazard manner. All the matching records will line up forming a row. For any record on one side, without a match on the other side, nulls will be padded. So for record E here, there is no match here, null padding. For record A, no match here, null padding. So basically we get everything and lot of nulls also, because wherever there is mismatch, there are no common values or matching data, it will put nulls. Apart from these four, which are the most frequently used join types, we have three more which are called as LeftOnly, or it is also called as LeftOuter join, RightOnly or RightOuter join, not inner or simply full outer join. Okay, in some tools, LeftOnly is called LeftOuter, RightOnly is called RightOuter, not inner is full outer. Depends on the tool again, the convention might change. Now here, LeftOnly means what? It is like A minus B scenario. Okay, if I think of this table as table A and this as table B, then I'm doing A minus B based on the join clause. Remember, our join clause is this only. Okay, so A minus B means what? All those records which are present in A only, any common data should not come. LeftOnly, okay, or LeftOuter, LeftOnly or LeftOuter. We get data that is exclusively present only in the left side table. Only in the left side table. Any record on the left with matches on the right will not come. Exclusively from the left side, if we have anything, we can get it like this. This will be the output. A is exclusively present on the left side. And it doesn't have data from the right side, so nulls will be padded. RightOnly or RightOuter join, where it is like everything that is exclusively present only in the right side table, which is record E in our case. If we look at this data, E is the record which is exclusively present only on the right side, and it does not have matches in the other table, so null padding. And not inner. Not inner means except for the common data. Inner is giving us common data, isn't it? So not inner is the opposite of that. If inner is giving all the records which are present in both the tables, not inner will give us those records which are not present as common records. So A, which doesn't have a match on the other side. E, which doesn't have a match on the other side. Okay, so only those records without any matches will come. It would again depend on the join clause. Okay, join clause is equal to, which will give this for inner join. So for not inner, it's the opposite of inner, giving me the rest of the data. Okay, so these are the 7 very important types of joins. We again have cross join, there is self join, etc. But they are not so important or not as frequently used. Now I will demonstrate these on the PG admin tool, and then I will see if there are any questions. Okay. So first of all, I'll create both the tables. The queries. Yeah. So that I don't have to waste much time here. Okay, so here is the table. I'm creating a table with the name courses, which has the name of the student and the name of the course. Okay, name of the student, we are calling it name, and name of the course, we are calling it course. So I'll run this query and courses is ready. Now I need to insert some data into it. So into my courses table, I'm inserting data for these 4 students, B, C, D, and E. Okay, I'm inserting data for these 4 people. Now I'll just do a select star from that table and show you the data. Okay, so B, C, D, and E, and this is the row level data that we have, all the records from there. Now I'm going to create a table for students where we will hold the name of the student in the name column and the age of the student as an integer. It is kept in the students table. Okay, and I'm going to insert some records in here. So the records I'm inserting are these. Insert into student, these are the values A, B, C, and D. This is the data inserted, and let us check the data from the students table. A, B, C, and D in one table, B, C, D, and E in another table. Now that the data setup is done, I'm going to write the queries. First, I need, let me demonstrate inner join. Okay, so we know that inner join will give us only those records which are present in common in both the tables. Matching records from both the tables will come. How to write the query? I need to select name and age. Okay, name and age from this table, comma. And I need name and course name with this one. Okay, this name and course name. So name and age I am taking from the students table. From the students table, and this name and course are going to come from the courses table. So I will say courses. Okay, if I just say this, and then I need to select these columns from these tables. Okay, if I just run it like this, it's going to throw an error. The problem is that the reference to the column name is ambiguous. We have a column with name as the name of the column in this table courses, and we have it in student details also. So it's getting confused on which column are you referring. Does this refer to the column under the courses table, or does this refer to the column under the students table? The names of these columns are not different. They are the same. So when you have columns with the same name present across different tables, you need to explicitly reference it through the table name. You need to explicitly mention what is the table to which that particular column belongs. So this belongs to the students table. So students dot name. So now when I prefix it with the name of the table dot column name. So this is the syntax is table name dot column name. Now there is no ambiguity. It clearly knows that this particular field column is basically the one from the students table. And if I run this, it will still throw an error because there is ambiguity with this name field. Still there is confusion. Okay. So this is something where I would like to refer to the courses table. Table name dot the column name. And when I run it like this, now there is no confusion. Okay, it understood that this is supposed to come from the students table. Then we need to take age. Why did I not prefix age with the name of the table? Because it is a unique name. It is not there across multiple tables. So when I say age, it is clear that it is from the students table. We don't have any field with the same name in the other table, so there's no confusion. Then course name and course from these two tables. And what exactly happened here? When I did this, what exactly happened here? It is doing Cartesian product. It is doing something called as Cartesian product or cross join. Okay, it's doing a cross join. So what does it mean when we say cross join or Cartesian product? Every row from one side maps with every other row from the other side. So A, which is present in student details, it got mapped with all the 4 records from the other side. D and with E. Similarly, B got mapped with all the 4 records from the other side. B, C, D, E. Okay. So if I have 4 records in the course table, in this table, I have 4 records in the other table, right? 4 by 4, I'm getting 16 rows in total. Every permutation and combination of data has happened. Okay. 4 rows from here mapped with 4 rows from there. So if I take A from here, got mapped with B, C, D, E from the other side. B from here got mapped with B, C, D, E from the other side. C from here got mapped with B, C, D, E from the other side. And D got mapped with B, C, D. If you look at it the other way, B from here got mapped with A, with B, with C, and with D. Similarly, C is also mapped with all the records. A, then C is mapped with B, it is mapped with C, it is mapped with D. Okay, like that. So kind of Cartesian product is what has happened, and this is definitely not helpful. We never do such a thing. Unnecessarily, it is leading to multiplication of the data. 4 by 4, 16 records. And imagine tables with millions of records, and if you do this. Okay. So we need to clearly specify how we would want to join. What is the join clause? What type of join and what is the join clause? Only when those things are specified clearly, we will get the desired output. So I need an inner join where I want to fetch these 4 columns which are present in 2 different tables, right? 2 columns are in one table and these 2 columns are in the courses table. I need data from both of them. By doing what? Okay, by doing what? I need data from students by doing an inner join with courses. By performing an inner join with courses. After saying that we are trying to join the 2 tables, students, inner join with courses, on which field the join clause should come? On name equal to name. If I do this, again, it will have the problem of ambiguity. It will not know which name we are referencing here from which table. There is confusion. So again, prefix it with the name of the table. Students.name means the column from there should be prefixed with and which should be matched with the name in courses, courses.name. Now that I have prefixed them with the name of the table to which they belong, so we are very nicely referencing them, properly referencing them. There will be no confusion. There will be no ambiguity. And look at the result of the inner join. It is giving us common data present in both the tables because the join clause is equal to student name equal to courses name. So name of the student in the courses table. That is why we got this result. Okay, this is inner join. Now, what if I would like to write a query that gets me the output of left join? What if I might want to do left join? I'll copy the same query. And instead of inner, I just need to change this to left. So students with a left join on courses. So students becomes my focus. Okay, the primary table, the main table is students where we get everything from them. Matches will be brought from the other side and with no match, nulls will be padded. Wherever there is no match, nulls are padded. Something exclusively present in the courses table will not appear because this is left join. Focus is on the data in the students table. Now, what if I might want to perform right join on this data? So I'll just copy it. And this time I will say I'm interested in performing a right join on this data. So all I need to do is change the join type from left to right. Now, what kind of output will this particular query give me? It's going to give me the entire data from the right-hand side table with matches from the left-hand side table. And where a match is not found, null padding will happen. Okay. Now, what if I might want to do full join? Full join means what? We want everything from both the tables. Matching data should line up. Wherever there are no matches for whichever member, you have to put nulls. So all I need to do is change the join type to full join. Once I do this, it's going to give me the entire data from both the tables. Matching data is lining up properly, and whichever member does not have a match on the other side, null padding is happening. That is full join. Okay, now how do I get left only scenario? Okay, left only join, or in most tools it is called left outer join. How do I get left outer join, which is equivalent to left only scenario? Data exclusively present only on the left side table. Okay, if I go and write left outer here, it works in some tools, it doesn't work in Postgres. If we write left outer, it will give us simply the left join output. Left and left outer both are giving us the same result in Postgres. In other tools, you will get different output. Here, both are giving us the same output. So how do I somehow fetch only the data present exclusively on the left side? So notice one thing. For data that is present exclusively on the left side, when we say that a record is present exclusively on the left side, it means there is no match for it from the right side. And if there is no match, nulls will appear, null padding will happen. So I need to perform a left join, get this result, and then I need to limit the data to only those records where here I have nulls. I hope you are able to understand this logic. Left only scenario. How do I get left outer join scenario or left only scenario? Okay, I need to perform a left join, get this result, and then put a where condition to focus on fetching only those records which don't have matches on the right side, for whom we have nulls on the right side. Then it will give me only this record. So I'm going to put a where condition here, where from the courses table, the name is null. Not equal to null, we can say is null. Okay. So when I run this, so from the courses table side, courses.name field, if it is null, I need only that record, which is nothing but the left only record. The record that is present only in the left side. If I run this, you can see the output. Left only scenario has to be achieved like this in PostgreSQL. In other tools, if you simply say left outer join, it will work. Okay. Now with right outer join, how do I get right outer join? So for that, let me run this right join and show you. This is right join. If I change that to right outer join, it will give me the same output. It is not going to change. Now let's focus on getting right only. What is right only scenario, right outer join scenario? Data that is exclusively present only on the right side, which does not have a match on the left side. Data exclusively present in the right-hand side table without a match on the left-hand side table, which means these records with matches should be ruled out. I need only this record which doesn't have a match here, meaning I basically need the right join scenario only. Okay, I need this query itself. However, I'm going to put a where condition, where data on the other side, data in the student side is null. You see, in the student table, I need to have null. So students.name is null. Oh, sorry, I think the language got changed. Where students.name is null. So when I run this query, what will it do? It will first generate write out join result. Then it will put the where condition. Okay, and it is going to fetch those records where the name here is null. So if I run this, I will get data only for E, exclusively present on the right side. Okay, that is write only scenario. Now, how do we get a full outer join scenario or not inner scenario? If I run full outer join or full join, in both cases, it's going to give me the same data. Because in Postgres, it does not work. If you just say full outer, it doesn't work. But how do I replicate that full outer scenario? So by now, I'm sure you all have the answer in your mind. Just think over how to get not inner scenario, how to get the output for not inner scenario, which is also called as full outer join. Okay, I have to run the full outer join query, which fetches me the entire data. And then I need to put a where condition. What do we need? If data from here is null, we need it. Or if data from here is null, we need that also. Except for those records which are matching, which have matches, meaning which are the common records. Okay, we need everything else. So not inner means what? Think of the set theory. Okay, Venn diagrams that we learned in school. This is courses table. Okay, this is students table. This is courses table. Inner means what? Matches from both the tables will come. This is inner join, isn't it? This is inner join. So B, C, and D will be as the common data. These are the common records in both the tables. So here I have B, C, and D. Something exclusively present in students only is student A. Exclusively present in courses only is student E. So we need this part and this part, not inner. Except for the inner, data exclusively present here and here is required. So how do we focus on that? Where either the student name is null, okay, the data in the student table's name column is null, or the data in the courses table name column is null. In either case, we need it. Or is the logical connector between the two statements. What will or do? Whether this condition is true or this condition is true, it will give us true. If one of the conditions is true, or if both of the conditions are true, it will give true. Only when both the conditions are false, it will give false. Okay, so if one of the conditions is true also, it will work. So if I run this, you can see how I got A, which doesn't have a match on the other side, E, which doesn't have a match on the other side. Okay, so this is not inner scenario. How do we get not inner result? So these are the 7 most frequently used join types in real time. When data is present across multiple tables, and for whatever reason, when we have to join that data, bring it together, then we must use this kind of a query. Okay, joins. Depending on your requirement, you can either go with inner join, or you could go with left join, you could go with right join, you could go with full outer, full join, full outer join, left outer, right outer, self join, cross join. Many options are there, different ways in which we can join the data. Okay. Now, what exactly happened with joins? When we say join, what is happening exactly over here? 2 columns, whatever number of columns in one table are combined with whatever number of columns are in the other table. So 2 from here combined with 2 more from there, giving us 4 columns, and it is extended horizontally like that, right? Lot of columns have come. And then the number of records, the result of the join would depend on the data in the tables, how much data is there in each of those tables, and also on the type of join that we have applied. What type of join did we apply? It depends on all of these things. Okay. Now, we will talk about a concept called as unions. The next thing is unions. How is unions different from joins? So joins is where we combine columns and the number of records or tuples will depend on the data and the type of join applied. Okay. Unions, on the other hand, is where you have to combine the rows. Unions is when you would like to combine the rows. Concatenation, like appending the data. Okay. Append the data from multiple files together. So what does this mean? Now let's say, I'll show you one very small example again on this to explain the concept. Okay, so let us assume that there is a business where they create a new file or a new database or a new table to store the transactions happening in each month. Okay, so let's say all the transactions which happened in the month of May are kept in a file, and this is the structure of the file. Then when the next month starts, June, they create a new table or a new file where all the transactions happening in June are stored. Details about the transactions happening in the month of June are kept over here. Then comes another month, July. So what do? In July, again, they create a new file or a table, and all the transactions happening in the month of July are kept over there. Okay, this is how they are storing the data from across multiple tables. Okay, now, if I have to combine all the data, let's say I've been asked to take data from May file, from June file, from July, August, September, whatever number of files could be there. I need to take all that data and combine that data and create one common file and analyze that data together, not separately, but I need to put all the data together and analyze it. So in that case, how do we do it? We are not talking about combining the columns. We just need to append the rows from multiple tables together and combine it together. So how do we append the rows? What we will do is, first I will create those tables. Okay, just a moment. Okay, I'll very quickly write the statement. So I'm going to create table for May. Okay, and the structure of the table is we have the day when the transaction happened, which we can keep as integer, the name of the customer, which I'll keep as varchar, then the number of purchases made by the people, which I will keep as integer, and the mode of payment. Okay, I will just say purchases and type. Type is also going to be of type varchar, whether they used cash or credit to pay. So this is the structure of the table: day, customer, purchases, and type. So once I create the table for May, I'm going to insert some records very quickly, or I'll create the table for June. And I'm going to create the table for July. Okay, data for all the 3 months. Tables to store the data from all the 3 months is ready. I will try to simply import the data. Okay, so for May, I'm going to import the data from the file. We had seen earlier how to import the data from a file. So I'll just select May, open. Here you need to make sure that the header is turned on, because in that file, the first column is row is the header and the list of columns are there. Now, when I click on OK, it should import. Yeah, process completed. Now I will import the data for June also. You can write simple queries also to insert the data, because here it's not much data. Very little data is there, three records. So you can directly write a query to get the data. And I'm going to very quickly import the data for July as well. Cross-check everything and click on OK. So now I have data also which has come successfully from the CSV files in here. So I'll show you the data from May. We have data for these three people from May. June, I have the data for these three people, A, B, C, then D, E, F, and GHI. Okay. Now, if I do a join, what will happen? It will simply combine all the columns, and that's not our intention. We don't want to combine columns from here with columns from another table with columns from another table. That's not our intention. We don't want to combine the columns. Our intention here is to perform a union. So how do I write a union query? Is select everything from May. Okay, I need to select everything from May and union it with everything that is selected from June and union it with everything that is selected from July. So that's simple. We just have to use the union keyword clause. Okay. So select everything from May, union it with whatever data is selected from June, union it with the data that is selected from July. So now what will happen when I run this query? Look at the output. The union output is what we obtain. Okay. Let me order by customer. Yeah. Now look at that. So we have everything from May, ABC, then DEF who belong to June, and then GHI who belong to July. Okay, so data from May, June, and July combined together. So what exactly happened here? The rows have been combined, not the columns. The rows have been combined. We are simply appending the data from different tables and bringing it together into one table. Now, what if you might want to use this data for further analysis in some other tool? I want to connect to this data from Tableau or from Power BI and then analyze this data. So I could actually go and export this, save this information into a separate file if necessary. So when I click on this, save results to a file, union output, I'm calling it, and I will put it on my desktop. Save. You can save it in CSV format only. You can't save it in Excel format. There is a limitation. You can save it in CSV format. So once I click on this button and I save the data, you can see it will be there on my desktop, union's output, and you can see the result. Okay, A, B, C, D, E, F, G, H, I, all the records are combined together into one single file. So we performed a union query, unioned the data from three different tables, and then brought it out. The union data has come out. Now, what if you don't want to store it externally into some other file, but here itself, within Tableau itself, you want to store it as another table? I want to create a table with all this union data. We can create it. I can use create table and give some union output, some name to the table, and the data in this table. What should be the data? This table is supposed to be created as what? As union on all of these. So it will perform a union on all of this, and the output data will be stored into a separate table within this database. Okay, it will be stored as a table within this database. So when I just go and run this query, it's going to create a table called as output data. Let me refresh and show you. Look at that, union output. Okay, if I right click on it and go to view data, okay, all the rows from the table. If I go ahead and try to check all the rows from the table, you can see it's going to fetch all the data. Look at that. Okay, but this might be redundant, right? We already have data for May, we have data from June, we have data from July stored as separate tables. Now I'm creating another table with the union of all the three. So this is like unnecessarily we are wasting the space in that particular database on that server, right? On that server in that database, we are creating these tables, and tables will occupy physical storage. Data from the tables is stored on the server. It will occupy the space. It is physically stored over there. It will occupy some physical storage space on the server in the database. So instead of storing it as a separate connection, a separate table, we can also create something called as a view. Okay, we will discuss views also because we have time. I can create a view, give it some name. So when I create a view, what will happen is Tableau is going to union this data and it is going to store it under the name of a view. It is going to store it as a view. Okay, and you can see this views here. When you right click and refresh it, it's going to show the views created. You can see that union output view got created with all the columns in it. And if I see the data that is present in this view, I can even do a select star from union output view. Okay, and when we look at the data that is present in this view that got created, it's the same data. So what's the difference between a table and a view? Table will consume physical storage in the database on the server, whereas view is simply a projection of the data. Okay, so tables are still present as separate tables, May, June, and July. But when you run this, when you create a view, okay, what happens is it's not going to physically store this unioned output in the database. Instead, it will project onto those tables. It will perform the union, and the result of that union is stored over here, is displayed to us. So whenever you run the query to fetch the data from the view, it projects onto those tables. It remembers that it is supposed to bring the data from these three by unioning them. So it will project onto those tables, take the data and give you the unioned output. Okay, so the difference between table and view is table is physical. It will occupy physical storage. View is logical. When you run it, it will project onto the table and then it will fetch the data and show it to you. But it will not consume any physical storage inside the server. That is the difference between a view and a table. Not just the result of the union output. Whatever you want, you can store as a separate table. Suppose I want to take this full outer join scenario and I want to save this as a view. So I can just say create view as. That's all. Create view, give a name to the view. Create view followed by that view name, and then whatever is supposed to be stored in that view, which is the result of okay, some problem with the, which is the result of the join. Okay, once we have created the join output. Correct only, no? As okay, I'll check this. So like that, you can create views, you can create tables with the output data that you have generated, and you can project, you can see the data that is present in there. Okay. So we have also touched upon the concept of views. All right, I will look into the questions now. If you all have any questions related to anything, you can put it and I shall look at the questions. So we have talked about views as well, okay? Apart from joins and unions, which was in the plan. We managed to talk about views also.